we are just going to revise division method by looking at a few problems, and before taking up the next type of problem, we will just revise that, what we have done. So square root by division method, let's take a number. Now let's say we have to find the square root of this number 3481 using division method. So the first step will be to group the numbers. Now how the grouping has to be done? Grouping has to be done in twos starting from the units digit. So this 81 will be one group and 3/4 this will be another group. So two groups will be there. And after that I have to start with the long division method. So this 3481 will be written in this way. This bar I am putting only for your understanding that these are divided into groups. Now you will think of the first perfect square number which is closest to 34. That is the first group of numbers. So the perfect square that is closest to 34 is 5 5s are 25. So you will write it in this way. 5 into 5 is 25. And then subtract. So why I have written 5 5s are 25? Because the next square number, that is 6 6 are 36, will be greater than 34. So I cannot have a number which is greater than 34. It has to be little less than that. So I have chosen 5 5s are 25. Then you will subtract 34 minus 25. You will get the answer as 9 after subtracting. Then the next step is that this next group of numbers will be brought down. So in division you bring a single digit down, but while you are finding the square root, since we have grouped the numbers, this entire group will come down together. So 81 will come down as a group. Then the next step is you will double this digit 5, it will become 10. And I am leaving a blank over here. This blank has to be filled with a digit in such a way that when you multiply that number with the same digit, you should get either 981 or something which can be less than 981 also, in case if it is not a perfect square. Now we don't know whether this is a perfect square or not. Okay, so we can try using different numbers. Now assuming that if it were a perfect square, then I can try with 1, because 1 into 1 will give me the ending digit as 1, or I can try with 9. Now 101 into 101 is 101 only, so that is not possible. So let me try with 9. If I multiply this with 9, that is 109 into 9, if I do, then I will get 81, 981. So then this digit to be filled here should be 9. 109 multiplied by 9 is 981. Then you will subtract these two, you will get the answer as 0. So which means the square root of 3481, the square root is 59. This is the answer. Now we got the remainder here as 0 because 3481 was a perfect square. Now what if this was not a perfect square? In that case the remainder will not come as 0. So let's take another example and see that. So let's take 1989. This example I am taking, and let's try to find the square root of this. So first step is to group the numbers. 19 is one group and 89 is another group. Then we will divide. So 1989. Now when I think of the nearest perfect square of 19, I can say 4 4s are 16 is the nearest perfect square of this, because 5 5s are 25 will be greater than 19, so I can't have that. So then 19 minus 6, after subtracting I will get 3, and then next step is to bring this group 89 down. Then the next step is to double this number, so it will become 8. Now I have to again add a digit over here and multiply with the same digit, and try to see if I get this number 389 or not. I don't know if it's a perfect square or not. So let's say 83 into 3. Because the ending digit is 9, I'm going to take a chance with 3. 83 into 3 if I do, I will get here 249, which is less than 389. So I can go for a little bigger number. So let's try 84 into 4. So 4 4s are 16 and I will get here 336 as the answer. So 84 into 4 is 336. Again it is little lesser than 389. So I can try with 85 into 5 also and see what I get. So 5 5s are 25, 5 8s are 40, 42, so 425 I am getting here, which is greater than 389. So I cannot try 85 into 5. So then it should be 84 into 4 is 336. So I am not getting 389. I am getting something which is lesser than this. So when I subtract, I will get the remainder as 53. So this is not a perfect square number because you are getting the remainder as 53. But if you subtract 53, then you can get a perfect square number. So if you do 1989 minus 53, then the resulting number that you will get will be 1936. And 1936 will be a perfect square, and square root of 1936 will be nothing but this number which you get above as the quotient, that is 44. So if you need to subtract some number to make it a perfect square, then this is the method. You will divide and you will see what is the remainder, and that remainder will be subtracted to get a perfect square. Now if you write any number which is not perfect square, let's say if I write 17. Now 17 is not a perfect square number, but I can either add something to it or subtract something to it to make it a perfect square. So for that the method is, now 17 lies between two perfect square numbers. So since it is a very small number, we already know which are the perfect square that it lies between. So if you think of the number which is less than 17 and is a perfect square, then it will be 16. 4 4s are 16 and 5 5s are 25. So these are the two perfect square numbers between which 17 is lying. So if you need to subtract something from 17 to make it a perfect square, then I can say subtract 1 to make it a perfect square, you will get 16. If you have to add something to make it a perfect square, then you have to go to the next perfect square, next bigger square. Now next bigger square is 25. So if you have to add something to 17 to make it 25, then it should be 8. So if you have to add something, it has to be 8. If I add 17 plus 8, I will get 25. So that is a method for adding and finding out the number, which you have to go to the next perfect square number and then you can make out what can be added to make it a perfect square.